Two boxes which weigh 20 pounds and 10 pounds are placed in an aircraft so their distance forward from the CG are 6 feet and 5 feet respectively. How far aft of the CG should a third box weighing 5 pounds be placed so that the center of gravity will not be changed? Okay, so we have our aircraft here, and we have the center of gravity drawn with the blue symbol. So we need to understand that what the center of gravity is. The center of gravity is the place where the force of gravity will act at a point in that object. At least we represent that mathematically. So with like a basketball here, the center of gravity would be directly in the center of the sphere because all of the mass is distributed around this point evenly. With a truck, a jacked up truck, it'll have a higher center of gravity. From the ground up, it has a higher center of gravity than, per se, a sports car like this would have a lower center of gravity, meaning it's closer to the ground. But the point is, every object will have a center where gravity can be mathematically represented to act through that point. With our aircraft, our center of gravity, it depends on how the aircraft is loaded, the design of the aircraft. So in this case, the center of gravity on this aircraft is just located right there. What that means is that the amount of torques that are on one side of the aircraft equal the amount of torques that are on the opposite side of the center of gravity. So these torques on this side equal the torques on side 2. So the torques on side 1 equal the torques on side 2. But when we're doing the evaluation for weight and balance, instead of using the word torque, we're going to use the word moment. So what is a torque? Torque is equal to force times a distance. We learned about this in physics with our first class lever. We'd have a force acting on this first class lever, and this lever would rotate around the fulcrum, and this force was applied at some distance from the fulcrum. The distance or the force, if either one of these increased, it would increase the amount of torque that was placed on this lever. And that's a similar concept here. So what we have is, all right, we've got instead of a torque, again, we're going to call it a moment. So what is a moment? We have an equation that we're going to use, and it's wham. So our equation is wham. So just like torque equals force times distance, we have our force, which is in units of weight. We know that force is in pounds. So there's our weight times our arm, like a lever arm, times our distance equals our torque. So instead of using the word torque, we're going to use the word moment because we're doing a static calculation here. Okay, so that being said, let's go ahead and add our boxes here. So we have a 20-pound box, and then just for our purposes, we have this. We can also think about our center of gravity as the fulcrum of this aircraft. So everything is going to rotate around the center of gravity. It can be tipped nose down, it can tip nose up, or it could have a level attitude, meaning it's just level like as pictured here. Center of gravity, you can also think about it as if I was going to place a string and attach it to this aircraft and I didn't want it to tilt forward or tilt backwards, I would place that string to where the torques on one side 1, equal the torques on side 2. That would be the center of gravity. And in our case, we can use it as also, it's like similar to the fulcrum. So we've added a box here, and this box is located at 6 feet from our center of gravity. So we've added a second box, which is 10 pounds, and this box is at 5 feet from our center of gravity. So what we've done here is added 2 weights a distance away from the center of gravity, which created 2 new moments on this aircraft. If the center of gravity if we were able to allow it to shift forward, that would balance out this aircraft. If we shifted the center of gravity forward, then we would essentially be putting more weight behind the center of gravity, balancing out the new weights that we added to the front of the aircraft. but it's the question's asking us, it does not want to be the center of gravity to be shifted. So in that case, what we can do is add a weight in the back. In this case, it tells us the weight is 5 pounds. So that could be similar to what is called a ballast. So a ballast is just a weight added into the aircraft so that we can move the center of gravity where we'd like it to move. But in this case, would be adding maybe a ballast to keep the center of gravity where it's currently located. Okay, so how do we go about solving this problem? So we need the moments on side 1 to equal the moments on side 2. So we've added 2 new moments on side 1. So we need to figure out what those moments are. So we're going to use our equation wham, and we know that the weight of the first moment is 20 pounds, and it's at a distance, or a lever arm distance, of 6 feet. So 20 times 6 is 120, and the unit is foot-pounds because it is similar units as the torque, or the exact same units as the torque. And we also have a second box that's 10 pounds, and it is located 5 feet away from the center of gravity. Therefore, it's creating a 50 foot-pound moment. So we need to total our 2 moments up, so it would be 170 foot-pounds would be our moment 1. So we know that we need our moment 1 to equal moment 2. So moment 1 is 170 foot-pounds. So moment 2 must be 170 foot-pounds. Otherwise, there would be some rotation, some tilting happening. But if they're both the moment on this side equals the moment on this side, then it will have a level attitude. Okay, so how can we get moment 2? So we're going to go back to our equation, wham. So we have wham. We know, what we do know is that there's 5, the weight of the second or the third box is 5 pounds. What we don't know is the arm. We're trying to find the arm. But we do know that that moment needs to be equal to 170 foot-pounds. So the last thing to do would be to just solve for our arm. In that case, what we need to do is just divide both sides by 5. We know 5 divided by 5 is just 1, so we're left with 1a. And 170 divided by 5 is 34 feet. Well, 34. If we were going to keep the units here, it would have been feet. Perfect, so 34 feet. And that would be our solution.